Hi there. We're in my home laboratory, otherwise known as my kitchen. We got dinner cooking here on the slow cooker. All right, see that? We got chicken. And over here on the stove, we've got water boiling. So now, we're gonna turn the flame off, and we're gonna we're gonna get the hot pad, and we're going to pour the water into the teacup. There we go. Now we're going to turn on the cooking thermometer, and we'll place it into the tea water, and we'll get a measure of our initial temperature there. Looks like the initial temperature is about 176 degrees. And then we'll come over here and check the ambient temperature in the thermostat in the dining room. And the ambient temperature looks like that's 73 degrees. All right, now we've gone from my kitchen to Desmos, and I have entered the data that I collected from the cooling tea into the table in Desmos. And you can access the table feature from the menu up here. You would just click on table. All right, so I've done that, and I've added the points I took from 1 minute through 10 minutes. And here are the temperatures of the tea at the end of each of those time periods in degrees Fahrenheit. And then I switched to intervals of 5 minutes, and you see that here up to 30 minutes. And I finally had a temperature of 116 degrees. Now, my initial temperature I have here at 180 degrees. You'll recall in the video I had a slightly lower temperature, 177 degrees, I think. After I got back from checking the thermostat in the dining room, I found that in fact the thermometer was at 180 degrees, and that's when I started the timer. So I went ahead and took that measurement. I'm not sure why the thermometer was a little bit lower initially. Maybe it itself was coming up to temperature. All right, you see these data plotted over here, all right? And we're going to plot on top of that our solution based on Newton's law of cooling. So I've entered over here to the left the ambient temperature that we pulled off the dining room thermostat of 73 degrees, the initial temperature which I pulled off the food thermometer that was in the tea, 180 degrees. Now here we have the particular solution with our initial temperature and our ambient temperature, although I don't have a proportionality constant K. All right, so I've entered that as a slider. All right, so let's display the curve, and you see that that's not too bad. But we can vary that curve by varying the value of K. All right, so what we're going to do is we're just going to adjust the value of K until we get the best fit we can. All right, it's probably somewhere right in there. All right, the value of K would be determined by the makeup of the teacup, for instance. And you'll recall that in the analyses like this that we did in class, that you've seen me do in the videos, we take one of the points other than the initial condition point, and we use that to calculate our value of K. Here we're actually essentially using all of the data that we've taken to find the value of K by varying the value of K until the curve seems to, at least by visual observation, best fit the data. All right, so there we have it. A reasonably decent approximation of our data is had with our solution from Newton's law of cooling. And keep in mind that there's probably a fair amount of experimental error in my data collection. Bon appetit. All right, see you in class. Take care.